The Andromeda Galaxy has always been a focal point in our understanding of the universe. It shattered the old belief that the cosmos revolved around the Milky Way, showing that we are just a tiny part of a much larger universe. For over a century, our knowledge about Andromeda has been limited to what we could observe from Earth. But now, with the James Webb Space Telescope, we are seeing Andromeda in a completely new light, and the latest data has left scientists astounded. A century ago, the Milky Way was seen as a faint, wispy band of light across the night sky. This perception was due to the limitations of early telescopes, which couldn't resolve individual stars. Galileo Galilei, in the early 17th century, used his improved telescope to reveal that the Milky Way was a vast collection of stars, planets, and other celestial objects, changing our understanding of the universe. In the 1920s, Edwin Hubble made a groundbreaking discovery using the 100-inch Hooker telescope at Mount Wilson Observatory. He observed that distant nebulae were actually separate galaxies, each containing billions of stars. One of the closest of these galaxies is Andromeda, also known as M31. This galaxy has been studied for centuries, with Persian astronomer Abd al-Rahman al-Sufi describing it as a small cloud in the 10th century. In 1612, Simon Marius provided a more detailed telescopic description of Andromeda. Charles Messier later catalogued it as M31 in 1764, mistakenly attributing its discovery to Marius. Over the years, astronomers have built on each other's work, gradually unveiling the secrets of Andromeda. In 1864, English astronomer William Huggins made a significant leap by studying Andromeda's spectrum and noting it differed from a typical gaseous nebula. This observation paved the way for understanding Andromeda's true nature. Today, scientists estimate Andromeda's mass to be between 1 and 2 trillion times that of our Sun, making it a colossal structure in the universe. Recent research has revised our understanding of Andromeda's mass and size. Although it might not be as massive as once thought, it's still larger than our Milky Way, with a diameter of about 220,000 light-years. This highlights the challenges of accurately measuring galactic masses and underscores the complexity of our universe. One of Andromeda's most intriguing features is its active galactic nucleus, AGN, a highly energetic region at its center powered by a supermassive black hole. Observations reveal 2 points of intense radiation, indicating complex gravitational interactions between the black hole and surrounding stars. Andromeda also contains an abundance of globular clusters, dense groups of stars orbiting the galaxy's center. These clusters offer valuable insights into Andromeda's cosmic history and interactions with smaller galaxies over billions of years, adding to its rich diversity of stars. Excitingly, scientists predict that the Milky Way and Andromeda are on a collision course. This massive event is expected to begin in about 4 billion years and will eventually merge the two galaxies into a new supergalaxy. The merger will trigger gravitational forces that distort both galaxies, create bursts of star formation, and possibly form a new type of galaxy. During this merger, the night sky will transform dramatically, showcasing new constellations and stellar arrangements. This cosmic event will also affect our solar system and Earth, potentially disrupting habitats, shifting biodiversity, and altering climate patterns. However, this process will unfold over billions of years, long after humanity as we know it has disappeared. Our Sun is expected to become a red giant in about 5 billion years, likely making Earth uninhabitable. The ultimate fate of our solar system in the new supergalaxy remains uncertain. The merger of the Milky Way and Andromeda raises fascinating questions about the future of life in the universe. Could new habitable zones emerge? Might unique forms of life develop in this new galaxy? While these questions are speculative, they open up exciting possibilities for the future. For now, we continue to explore and marvel at the Andromeda Galaxy, from ancient observations to the latest discoveries by the James Webb Space Telescope. But this is just the beginning. The James Webb Space Telescope, with its unprecedented capabilities, has revealed more than we ever imagined. It's not just about the scale and mass of Andromeda, but also about the dynamic processes occurring within it. The telescope has uncovered evidence of intense star formation, regions where new stars are being born at a rapid rate. These stellar nurseries are fascinating laboratories where the raw materials of the universe coalesce to form new stars and planetary systems. Andromeda's supermassive black hole, located at its heart, is also a subject of intense study. This black hole is millions of times the mass of our Sun, and its gravitational influence extends far into the galaxy. The matter spiraling into this black hole forms an accretion disk, heating up and emitting powerful radiation. This process makes Andromeda's core one of the most energetic regions in the galaxy, visible across vast cosmic distances. Globular clusters in Andromeda are another area of intrigue. These clusters are ancient, some as old as the galaxy itself, and studying them can provide clues about the early history of Andromeda and the universe. These dense star clusters orbit the galactic core and contain hundreds of thousands of stars packed into a relatively small area. They are key to understanding the formation and evolution of galaxies. The impending collision between Andromeda and the Milky Way is a cosmic event of unprecedented scale. As the galaxies draw closer, their mutual gravitational attraction will cause tidal forces that distort their shapes, triggering bursts of star formation as gas clouds collide and compress. These interactions will create new star clusters and possibly new planetary systems, reshaping the structure of both galaxies. When the collision occurs, it will be a dramatic event in the night sky, visible to any future civilizations that might be around to witness it. The merging of the two galaxies will take millions of years, resulting in a new, larger galaxy with a different structure. This new galaxy could be elliptical or disc-shaped, depending on the dynamics of the merger. The effects on our solar system could be profound. As the galaxies merge, the gravitational forces at play could alter the orbits of stars and planetary systems. There is a possibility that our solar system could be ejected into intergalactic space or find itself in a completely new galactic environment. These changes could impact the stability of planetary orbits and the conditions necessary for life. Moreover, the increased activity in the new galaxy, including supernovae and gamma-ray bursts, could pose risks to any life forms present. These high-energy events can have devastating effects on planetary environments, stripping away atmospheres and making conditions hostile to life. However, it's important to remember that this cosmic ballet will unfold over billions of years. Human civilization, as we know it, may not exist to witness these events. By then, if humanity survives, it would have evolved into a form unrecognizable to us today, possibly having spread to other stars and galaxies. The study of Andromeda and its eventual collision with the Milky Way provides a glimpse into the dynamic and ever-changing nature of the universe. It reminds us of our place in the cosmos and the ongoing processes that shape the galaxies we see today. Andromeda also holds other secrets that are yet to be uncovered. The James Webb Space Telescope continues to gather data that may reveal even more about this fascinating galaxy. For instance, the detailed study of Andromeda's star clusters and their motion could provide insights into the dark matter that permeates the galaxy. Dark matter, which makes up a significant portion of the universe's mass, is still one of the greatest mysteries in astronomy. Understanding its distribution and influence in Andromeda could help us unlock the secrets of the universe's invisible components. The telescope has also started to reveal the detailed structure of Andromeda's spiral arms, showing regions of star formation and the intricate dance of gas and dust. These observations help us understand how galaxies evolve and how new stars and planetary systems are born. Each new discovery adds a piece to the puzzle of how our universe works. The Andromeda Galaxy's interaction with its satellite galaxies also provides a rich field of study. These smaller galaxies are gradually being pulled into Andromeda, merging with it and adding their stars to its vast collection. This process of galactic accretion shows us how larger galaxies grow over time and how the universe builds its grand structures. But perhaps the most exciting aspect of studying Andromeda is the potential for finding exoplanets within it. As our technology improves, we may be able to detect planets orbiting stars in Andromeda, opening up new possibilities for finding life beyond our own galaxy. The discovery of exoplanets in Andromeda would be a monumental achievement, providing new targets for future exploration and study. As we continue to observe and learn from Andromeda, we are reminded of the vastness of the universe and our small place within it. Each new discovery brings us closer to understanding the cosmos and our role in it. The journey of discovery is far from over, and the James Webb Space Telescope is just the beginning. So, what do you think about these incredible revelations from the James Webb Space Telescope? How do you think humanity will cope with the knowledge of such cosmic events? Share your thoughts in the comments below. If you found this video enlightening, don't forget to give it a thumbs up. Stay tuned for more cosmic insights, and as always, we'll see you in the next one.